Hey guys, I know it's been a while, but I'm finally back and I will complete the R6 drone series. It's been a couple of years since I made my last video, and back then my understanding of code was really basic, and I didn't have the resources or knowledge to complete this. Now that I'm in college, not only am I more knowledgeable, but I have more money and access to 3D printers. Here is what the final drone will look like. Keep in mind that I'm only teaching you how to make the functional build. If I wanted to make it look more like the real drone, I would just 3D print a black cover piece for it. Also, I'm aware that it is really tough to get your hands on some of these parts. For example, I'm using a Raspberry Pi here, as it not only costs a lot more, but it is in low supply. So if you guys ask, I can make an ESP32 version. It is unlikely that that version would have a camera though. Okay, now that everything's ready, we can get right into it. Okay, so let's go over what the final product would look like. So here's the drone and here's my laptop. And what the drone does is it hosts a web page so that any laptop can connect to it, and we can use WASD and look at the camera so that we can control it nicely. So let's just try it. So when I click W here, you're gonna see the camera move. And then we can turn the other way, and you can see that it's only using the keyboard. So this is what it'll look like, and this is why we're using the Raspberry Pi, because it can host a web page really well while also having this video stream run really fast, which an ESP32 would struggle to do. Okay, now let's talk about the parts. As I stated before, we are using the Raspberry Pi, and this is really handy as it is not only amazing at hosting web pages, but it also has cameras that are specifically optimized for it. So over here, you can see the RGCam 12 megapixel wide angle lens. This uses a ribbon cable that connects directly to the Raspberry Pi. Using the Pi camera library, we can get excellent performance compared to using an actual USB webcam, which is really slow and draws too much power. This purple base plate that you see is 3D printed. I will drop the file for it on my website. This part holding the camera over here was just hot glued on, and I didn't account for that earlier. And since school is over, I don't have access to 3D printers, so I can't get that fixed. The motors are pretty generic for these type of projects, and I will put a link below. The important part is that you need good traction tires. Before, I was using these mechanism wheels, which slipped on hardwood floors quite a bit. These wheels are from an old toy RC car, but the ones that I put in the description should be good. Then we have the legendary L298N. This thing, I absolutely love it, and this is the go-to motor controller for me. If you want a more in-depth guide, check out my other video over here. For this setup, I put jumpers on the enable pins, which means that these motors are always set to 100%. I can only control the direction, and this makes the code a lot simpler. Now the batteries are really interesting. If you notice, I have two separate ones. And the reason for this is because one is just a regular phone power bank that I use to power the RPI, and the other powers the motors. I did this because I wanted my Raspberry Pi to have a very reliable and consistent amount of power so that it doesn't get damaged. You can use any power bank. The second battery is a little overkill though, and I had it lying around, so I just threw it on. So the speed of the motor is dictated by how many volts the battery is, so I recommend 7.4 volts and above. Be careful though. I believe that these motors are rated for a max of either 12 or 24 volts, so if you go above that, you will fry them. And this battery is rated for 6,000 milliamps, which is more than plenty and can probably power this drone for hours. And that's it for the parts. Now let's look at the schematic. If you watch my videos for a while, then you know that I used to go to using this NRF24L01. I don't really know why, but why should we just go with this? Why can't we just use something more reliable and easier like Wi-Fi? Look at how complex this looks, and look at how many points of failure there are. Look at all this huge jumble of wires. Instead, we have our new schematic. Whoa. As you can see, this is already 10 times simpler and so easy to look at. So let's just go through it. So first we have our power source, right? And this connects to our L298N board, where it just goes into 12-volt line, and then we have ground. And we also need to make sure that the Raspberry Pi's ground is also connected to this, so that the L298N knows that we're controlling it using this microcontroller or computer. So also notice that we don't use this 5-volt line. That's because we're powering it with the power bank, and also this 5-volt line can't provide enough power for the Raspberry Pi. If we were using an Arduino or ESP32, then we would use this. And now the motors, pretty simple. They just connect to each one of the outputs for each of the motors. And over here, as I stated before, we're using the jumpers. I can't show this in the schematic, but these are connected. These two pins are connected to each other, and these two pins, which allows the motors to run at max speed. And then for each of the input pins, we have it mapped to a GPIO pin. So yeah, this is how I mapped it. And in the code, we can see exactly which GPIO pins these are. Okay, now let's talk about what like the underlying code is doing. So since we're using Wi-Fi, one of the many protocols that we can use is HTTP, and that uses TLS, which is basically a way of sending data in such a manner that you ensure that the client receives it. So the way it works is that first you send a signal saying, hey, I want to connect with you. And then the server says, hey, I see you and you're allowed to join. And it sends an acknowledge back. And then after this acknowledge is received, then the client and server talk to one another. So the way this works is that there's a three-way handshake before things can work. And on each HTTP request, it does this three-way thing. So if you imagine, right, anytime you want to get something, doing three different back and forths is a lot, and that can waste a lot of time. So instead, we want to keep that connection open after we do it. So this is where we can use WebSockets. So the way it works is once the handshake is over, this WebSocket is open in a bi-directional way, so that the client can keep sending stuff and the server can keep sending stuff, and it only uses one like send. You don't have to do three sends. So this is way faster, and this is what we're going to use for the WASD part. And then the video, like we need that WebSockets aren't really designed for very high memory stuff or like high amounts of data, and videos contain a lot of data because it needs to send each and every pixel. So for this part, we'll use HTTP, and modern day stuff is already super fast, so there'll be like a very minor delay, but we'd rather have that minor delay on our video than our WASD because we want our controls to be instantaneous. So this is what we're going to use, WebSockets and HTTP, to get this working. Now let's talk about the code. So by the end of this, you should have a web page being hosted on the IP address of the Raspberry Pi with its port number, and you should be able to see the camera, and this is actually live right now, as you can see my fingers. So this is the goal. Now let's look through the code. As you can see, it's really simple. We just have two files of code, an HTML file to serve the page and a Python file to run the server. And then we have requirements.txt so that you can download all the requirements accordingly. If you don't know how to do this, just ask ChatGPT. It's really simple. And yeah. So now let's talk about this code. So here, there's just the simple imports. We use Flask to deal with sending the web page for the video and also for the sockets for the WASD part. And then we have GPIO, very basic, Pi camera, and so on. This is all just set up to get the Flask app running. And here's some of the code that's actually really important to talk about. So when you're setting up your camera, first use this command right here, as I used below, to figure out what resolutions and what FPS your camera supports. So as you can see, mine can do, I think this is a really high number, maybe 16K at 15 FPS. But we don't really want something super clear with really low FPS. We want like a real-time system. So instead, it's better to go with the lower resolution with a higher FPS. And I took this to the next level and used an even smaller resolution so that I can get really quick real-time sort of camera. And so yeah, this is where you can configure what exactly you want. And use this calculator here if you want to figure out possible aspect ratios. So I actually went over here and I put in what aspect ratio my camera takes. So then, you know, this 4608 by 2592. And I tried these numbers. So then I originally tried something like this, but that was too blurry. So then I went up to over here, but that was a little too laggy. And then I decided on 768 by 432. And you can also play around with this value. This is just like how it renders the image. I found that this worked for me, and without it, it makes everything look blue. Okay, then let's talk about the GPIO setup. This is very basic, very similar to Arduino, where we just set up our pins. And for this, I don't use the enable A or B pins anymore. I'm using the jumper. I'll take a picture of it and show you. So they're just set to 100% at all times. But if you want to control the individual motor speeds, do so. And I also made another video about this, and you can watch that if you want to go into how the L298N works. So yeah, this is just the basic setup. And then we can scroll down over here. This is how we actually set up the entire Flask app. So the home page itself just sends the index.html. So this web page. So this is like the home directory. And then after that, we have the video feed route. This is how we get this actual image. And I'll explain this a little more later. And here's where we set up all the sockets. So this just is the connect and disconnect. We just have to do this. And then when the user presses a key down, so when I click W, this is the code that runs on the server side or the Raspberry side. And then when you let go of the key, this is what the server runs. And this is again just like, you know, running the code, dealing with the ports and everything. This is not too important. So let's actually go over this part specifically and how it works. So what we do is when the user presses W, we add W to the active keys, which is just a Python set up here. So we add this to the active keys right now, right? So we add, okay, the user's pressing W. And what does this do? It goes to update movement. And as you can see, update movement controls the speed of the motors. So if W is in active keys, then we, you know, set both motors to forward and we set them to full speed. And then at the end of this, we have this function set motor speed, which takes in which motor we want to control, which direction we want to go, and what speed we want to go at. So then if we pass in left, you know, we can set all of those parameters and right. So the set motor speed just deals with the speeds. So then yeah, back to this function. We look at each of the keys and we have separate if statements to deal with each one of them. I'm not going to go too into this because this is fairly basic and you could cover this by yourself. And for the video feed, we can go over this a little. So this just gets the current frame. What a video basically is just a bunch of images put together. So we just get the current image of the camera. We render this using CV2, and we just send this to the user. And that is what's going to appear on index.html. So now let's talk about index.html. I'll put this side by side. And just a disclaimer, I did use ChatGPT to code this, but more so on the looks part. I'm not really familiar with CSS, so that's what ChatGPT could do for me. I'm just going to focus on the functional part. So I made a div where we upload the image, and this, as you can see, connects directly to this. So we look at the video feed and we just take the image from it and then we just show it here. So this is just an image, like a basic HTML image, but the image changes so rapidly that it looks like a video to us. And then after that, this part is actually the part where we use the WebSocket. So we set up the socket and then we connect it. So in this web page, we have these things called listeners, event listeners, where we can wait for an input from the user and do something about it. So when we click W, right, we can see that, okay, this page looks for when we press a key down, and then it will send this key to the server code. So it'll run this code here when we click W. So as you can see, it sends that key. And the same thing for key up when we let go of the key. And this is how all of the code works. Very simple, so much better than using the NRF24L01. And yeah, this is it.